Hello and welcome to my AS Physics tutorial on conservation of energy. So what is the conservation of energy thingy? Well, it's a principle. It's the fact that the total energy in is equal to the total energy out. And this is the idea that energy cannot be created or destroyed, but instead it can be transferred from one form to another. But the total amount of energy in a closed system, when I say a closed system, I mean anything like this motor here, will not change. And also, there are no outside factors that I could change in order to make the motor stop working. So that's what a closed system means. There's also the idea of efficiency. You get efficient cars nowadays, so it's the useful power output over the total power input. So when I say useful, I mean it's not being converted to heat energy. Useful is the movement energy, the circular motion energy in this motor, for example. So this idea is needed for kinetic and potential energy energy questions, which is what we'll have a look at now. So kinetic energy is an energy of anything moving. So the physics way to do it is to use EK equals half mv squared, where v is the velocity it's travelling at and m is the mass. And there are lots of different types of potential energy, like gravitational, elastic potential energy. So gravitational potential energy is the energy something gains if you lift it up. So you can work that out by using the change in potential energy, which is equal to mg delta h. We came across this before when working out problems. It's just expressed as mg delta h usually, but the change in potential energy is the missing part of our equation, and if you can remember that particular part, it will make the sums a lot easier, and rather than just being a mathematical expression, we can turn it into an equation when it's applied to conservation of energy. And if we use elastic potential energy, we can use the equation E equals half ke squared, where E is the extension and R, or rather K, is the spin constant. This is why you must always write your R's and your K's with longer tails. So now we'll look at some examples of the changes between potential and kinetic energy. So as we throw a ball upwards, kinetic energy is converted into gravitational potential energy. When it comes down again, that gravitational potential energy is converted back into kinetic energy. And if you bounce upwards from a trampoline, elastic potential energy is converted to kinetic energy, so gravitational potential energy, and as you come back down, the gravitational potential is then converted back into kinetic, and then to elastic potential, and it keeps going on like that. Also, another example would be a slide. So if you get a man and sliding down a huge water slide, excuse my crude drawings again, but that's a very simple example of GPE going to kinetic energy, KE. But in real life, you've got to appreciate that there are frictional forces. So in order to keep jumping to the same height on the trampoline, you'd have to use forces in your muscles in order to keep jumping to the same height above the trampoline every time. And each time the trampoline stretches, the heat is generated in the trampoline material, and you're always told to ignore friction in exam questions, So what it really means, what the examiners are looking for, is that you can assume that the only forces that are provided, the only forces are those that provide the potential or kinetic energy. That would be the weight of your person going down the slide, and for the trampoline example, the tension in the springs and the trampoline material. So if I had a really taut trampoline, I would need to apply more force in order to go up a bit more. So now we're going to have a look at using this principle to actually solve a problem. So I've got an example here. A simple pendulum has a mass of 700 grams and a length of 50 centimeters. It is pulled out to an angle of 30 degrees from the vertical. So first you find the gravitational potential energy stored in the pendulum bob. So you start off by drawing a diagram. Always draw a triangle if it involves trig. So you then do the horizontal component of this, 0.5 cos 30 meters. I got the 0.5 from the hypotenuse here, and what we need to work out is the increase in height h at the end of the pendulum. So it's this part here, h. So if we know that using mgh, we can times 0.7 by 9.81 and times that by 0.5, the hypotenuse, minus the horizontal, the horizontal component, cos 30, and we get 0.46 joules. Now for part B, the pendulum is released. We need to find the maximum speed of the pendulum bob as it passes through the vertical position. So if we use the equation mgh equals half mv squared, we can then cancel out the m. So we do that, we will get the expression v squared equals 2gh. So I'll just rewrite that, equals v squared equals 2gh. You can get rid of the half by simply timesing by 2 and timesing gh by 2 in order to get that expression on the second line. Now knowing this, you can do the same thing again. 2 times 9.81 times 0.5 minus 0.5 cos 30. Now this should get you the velocity 1.15 ms minus 1. Roller coasters are a big favourite of the EdXL exam board, and that's usually the situation that they go for, although in recent years they've used more abstract examples, to say the least. I will go through some more of these examples that I call abstract soon, so please comment if you would like them sooner. But for now, I'm just going to do this question that I have found from another source. So a skateboarder is on a half pipe. He lets the board run down one side of the ramp and up the other. The height of the ramp is 2 meters. Take G as 9.81 newtons per kilogram. If you assume that there is no friction, what would be his speed at the lowest point of the ramp? This is a 3-mark response. How high will he rise up the other side? This is a 1-mark response. And real ramps are not frictionless, so what must the skater do in order to reach the top of the other side? the top on the other side. That's 1 mark again. So I'll give you a 5-second pause, and okay, so hopefully you had a go at the question, and if you didn't, then I'm going through the answer. So using EK equals half mv squared, and the potential energy equals mg delta h, the change in height. So using half mv squared is equal to mgh, and then half v squared is equal to gh. We can then use v squared equals 2gh from previous example. 2 times 9.81, all in brackets, times 2 equals 39.24. So then square rooting 39.24 equals 6.26 ms minus 1. So for part B, you rise up the ramp by 2 meters, and there will be no friction. And for part C, you need to put more energy into the system by skating. Okay, so I hope you found this tutorial useful. Come back next time when we talk about Hooke's law and how extension is proportional to force, but more about that in the next tutorial. Thank you and goodbye.